Okay, today we are going to be looking at vertical shift. So we're going to be looking at moving up or down. These are all up. And graphing in ratings. Okay, so let's start with vertical shift. So these two problems from your notes are sample problems that you might have where you have to find the amplitude, frequency, and the vertical shift. You will not be asked to find the phase shift at this point, so that's good. So in doing that, we need to talk a little bit, okay? What is the amplitude? Amplitude is the height. So A represents the amplitude, which is the height. Okay, now we had a formula for the height. The height was half the difference between the max and min. So basically, it is max minus min divided by 2. So if I want to take a look at my problem here, I have a spring with a weight attached, stretches and contracts with time according to the graph below. The maximum length of the spring is 10 inches at 0.2 seconds, and it is at a minimum length of 2 inches at 6/10 seconds. If the equation of this graph is written, find ABC. So my max value is 10. My minimum value is 2. Now this might be a typo here. This needs to be a comma after the 0.6, not a decimal point. So 10 minus 2 divided by 2 is 8 divided by 2 is 4. So that means that you have a height from like a middle line, and that is 4. So that middle line looks like it's around here at 6. So this is 4, and that's 4, and this distance is 4, and that distance is 4. So that's our amplitude. Let's talk about this middle line just a second here. Okay, it's kind of like the new axis. Okay, so it used to be that our graphs are on the x-axis, but now they've been shifted. It's a vertical shift. They've been shifted up. And so this is kind of like a new axis, a new x-axis, okay? I call it a middle line because it kind of divides the sine graph or cosine graph right in the middle. And so how much has that new axis been shifted up? Well, you should be able to see it's been shifted up 6. Well, how would we get that vertical shift? So that vertical shift is equal to 6, okay? But how would we get that? Well, we should be able to, if you look at the max, how would you get, you take the max, you got 4, 10, 6, 2, how would you get the 6? Well, you could kind of look at the graph, or if they were decimals, you could look at taking the maximum value minus the amplitude, okay? So max minus the amplitude. And so our max is 10 minus 4, so our vertical shift is 6. So C is 6. That's how much it's been shifted up. And then B is the frequency. Now, we have a formula for frequency, and our formula is period equals 2 pi divided by the frequency, which is B. So what is the period? Well, the period is the total distance it takes to complete one curve. Well, we can see that that's happening by 8/10 or 0.8. So our period is 0.8. So 0.8 equals 2 pi divided by the frequency, B. So when I cross multiply that, I get 0.8b equals 2 pi, and when I divide by 0.8 on both sides, I get b is equal to 2.5 pi. So 2 divided by 0.8 is 2.5. So that is our frequency. Okay? So one other thing, how would I go about finding, like, if I was given this equation, so this equation now is really, y equals 4 sine 2.5 pi x plus 6. So that's really, my equation now. So, if I was given that, how would I find the maximum? Which we can see from the graph is 10. Well, look at the equation. What could I do to find that? It looks as if I added the vertical shift. So if I want to find the max, I can take the vertical shift and add the amplitude to it. Okay? And if I took to find my minimum, I guess that minimum of 2, I could take that vertical shift minus the amplitude if I was looking for a minimum. Okay, let's go on to the next one. Same idea. The effect of certain blood pressure medication is shown in the graph below. Assume that the effectiveness of the drug ranges from 1 to 10, with 1 being the least effective. The graph shows an 80-day period. The period may be represented as such and such. Find A, B, and C. So again, we're looking for amplitude, frequency, and vertical shift. So that amplitude is equal to, again, max minus min divided by 2. So our max is 10 from the graph, our min is 1, divided by 2 is 9 divided by 2, which is 4.5. For my frequency, again, I'm going to use period equals 2 pi divided by the frequency, which is the letter B. Now, the period is how long it takes to complete one curve. I am seeing one complete curve here by 40. So my period is 40, not 80. I'd see 2 complete curves by 80. So I'm going to do 40 equals 2 pi divided by B and cross multiply that. So I get 40 times B, which is our frequency, equals 2 pi, and if I divide by 40, I get a frequency of pi divided by 20. So that's in radians. Okay, so then that vertical shift. So to find that vertical shift, I need to find a middle line. So you can kind of see it here, but if I don't know it, I need to do the maximum minus the amplitude. So I'm looking for the middle line, or my new x-axis. And if I take the max minus the amplitude, I will find it. Now, the maximum value is obtained again by taking the amplitude plus the vertical shift. Okay, so I see my max value here is 10. My amplitude I found to be 4.5, so my middle line would be at 5.5, and that's actually labeled here. So that means that it's been, my x-axis has been shifted up 5.5, and that is my vertical shift. So again, if I were given the equation now, so it's y equals 4.5 sine of pi over 20x plus 5.5. That is the equation of my graph in radians, of course, because I've got the pi over 20. If I was looking at that equation and I wanted the maximum value to figure out, for whatever reason, if I was going to try to graph it myself, the maximum value is equal to the amplitude plus the vertical shift. Because to find that vertical shift, I took the maximum value minus the amplitude, so that should make sense. So my max is 4.5 plus my vertical shift, which is 5.5, so my maximum value is 10. And that's showing that. Okay, so now I need you to go about 1, 2, 3, 4, 5, 6, 7, 8. I need you to go to the page right before the very last page, which says Goals Checklist for Chapter 11. And it looks like this. So you're basically at the end of your notes, 1 page in, 2 pages in. It's kind of on the back of that second page in. All right, it's a good time. We should probably have put this in the notes at this point, but I didn't. So we're going to do graphs of the reciprocal functions next time. But we want to do this one. This is a graph in radians, and we're talking about these maxes and middle lines, so it's a good time to do this. So here's a problem. In 2008, the temperature in Fahrenheit of a city can be modeled by, and look at all those decimals in that equation. T represents the number of months that have passed since the first of the year. For example, T equals 4 represents the temperature at May 1st. So that means that means that at 0 months, we are talking about January's temperatures. And at 1 month, we are talking about February's temperatures. And at 2 months, we're talking about March. 3 months, we are talking about April. And 4 months, we are talking about May. And then all the way down to 11 months, we would be talking about December. Okay, so that's how we're going to do this. So now, it says graph f of t in the interval 0, 11. So that's an interval notation that means including 0 and including 11. So this one is going to be difficult to take, we can find the amplitude, frequency, the period, and the phase shift, but it might be difficult to do without our calculator, so we're going to have to use our calculator. So I am going to write down, though, my amplitude is equal to 12.1. My frequency, or B, is equal to 1/2, or 0.5. The period is 2 pi divided by 0.5, which is 4 pi. Now, we want to do this graph in radians. So I kind of right now want to know how many radians exactly 4 pi is. So I'm going to calculate 4 pi. So it's about 12.566. So that's about 12.566 radians. Okay. My phase shift, PS, phase shift, remember that's that left and right movement, is, and it needs to be negative C. Okay, so this is your C and this is your B. So it's going to be negative C divided by B. So that's going to be 1.4 divided by 0.5. And what that gives you is 2.8. So we'd be getting in almost So we'd be starting at 2.8. That's kind of tricky to graph that decimal. And let's see, what else? Our vertical shift, VS, is 71.3. Okay, so a couple of things. So PS is phase shift, and that's your movement left and right. And then VS is vertical shift, and that's your movement up and down. Okay, so now we can also find our middle line and our max. Okay, so the maximum was, if we go back a page, our maximum was our vertical shift plus our amplitude. So it's going to be vertical shift plus amplitude. So our vertical shift is 71.3, and our amp was 12.1. So my maximum value is 83.4. And then if I wanted to find that middle line, okay, and that middle line is the phase shift. Okay, so I mean it's the vertical shift, which is 71.3. So that's going to be important for some reasons I'll share with you. So what we're going to do now is put this in the calculator, and we want to be in radian mode. If you're trying to graph something from 0 to 11, you don't want that to be in degrees, because then that's going to be 0. It's just not going to work. You want to use radians, because radians, you can represent, 1 radian represents about 56 degrees. So rather than trying to do 0 to 11 and you're getting these little small, it's not going to work. So we need to be in radian mode. This is a problem where it is kind of telling you, in essence, you need to be in radian mode. Anytime you're going to go count things by 1, the interval is going to be 1, you need to be in radian mode. If your interval is 30, then you can be in degree mode. So let's take and convert this to radians. And then let's go to y equals and clear that out. And we're going to type this in. So 71.3 plus 12.1 sine 0.5x minus 1.4 and I'm going to go to my window, and the x min I'm going to make 0, and the x max I need to go to 11, but I'm going to take a look at it from 0 to 15. My x scale is going to go by 1s. My y min, I'm going to start at 0. And my y max, I need to know what that maximum point was, and it was 83.4. So I'm going to put my y max up to like 100. If you put it at the actual max at 83.4, if you say you put y max at 84, you will not be able to actually calculate what the actual maximum, to find it on the calculator. You can find it, it's just the words run into the graph itself. So I'm going to just do that and hit graph. And so it looks like a cosine curve, but it's a sine curve that has been shifted. There's your phase shift, so you can kind of see the sine curve too. There's the shift. So my vertical shift will give me my new x-axis. So I'm going to go into y2 and make that 71.3, so I kind of can see my new axis. There we go. Okay, then hit graph. Okay, so I'm only required to graph to 11, so maybe it would be easier to make this 11, that x max. Alright, so now I need my skeleton points here. So I can do second trace max. And I can get a little to the left of that max, go a little to the right, and then go on it. And I know the maximum value is already for y, 83.4. I needed the x, which is 5.9. And then I need to know the intersections with that middle line, which was 71.3. So I'm going to go second trace intersect, and enter, enter, enter. So it gives me one of them, which is 9.08, 71.3. And then second trace intersect again. I'm going to hit the down arrow, and then I'm going to go over. I need to get my intersection over there. There we go. Perfect. And then enter, enter, enter. So now that is 2.8, 71.3. So I've got those points. And then I'm going to go to second window and have my table increment by 1. So I can go into second graph, and I can see that at 0, which is one of my skeleton points, I'm at 59.37. And then at 11, which I'm asked to graph it to, I'm at 61.4. Okay, so that's how I got all my skeleton points that I need to graph. So now down here, I'm going to basically set this up so here's all my points. So this point is 0, 59.4, and this point is 11, 61.4. And I got those by just going to second window and having the table start at 0, and triangle TBL was 1. So same thing here. Second window, table start, and then triangle TBL, was 1. And then I looked at my table. Now to obtain this maximum point, this was 5.9, 83.4. So to get that, I just did second trace max. And then remember we had that middle line here, which was y2. So kind of like here's my graph. Oops. It's not the best little sketch that I got going on here, but it'll work. So I have y2, and that was 71.3, which was just the vertical shift. Okay? And then I did second trace intersect. I mean, you can look at all the points in the table as well, but the points in the table are not going to give you the max, or these key points. So this point here was 2.8, 71.3. And then this point here was 9.08, 71.3. So I have 1, 2, 3, 4, 5 key points to plot. So in plotting this, what I did was I went and I put 84 right at the top. I just started and said I'm going to go 84 there. My highest is 83.4. And then I went down by 4s. So actually by 2s. So this was 80. This was 76. 72. 68. 64. 60. 56. 52, and then this is 0 down here. I think I went like up 1. Oh, pretty good straight line. So this was 0, and then if this starts 52, I kind of just put a break in there. And then I went over and made this, that was kind of a break, so I made this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this x-axis was in months, number of months, and this y-axis was the temperature. Okay, so then I had my points and I plotted. So different colors. So at 0, I'm at about 59.4. And then 2.8, 71.3. The max was 5.9. 83.4, so that's way up here. And then 9.08, real close to 971.3 again. And then 1161.4. Okay, and then I will connect these. All right, so now this is not exactly reaching here to be symmetrical at 11. It's a little bit higher, so you should notice 11 was at 61.4 and 0 was at 59.4. I think for it to actually finish its complete cycle, it would have to go to 12, which would actually mean the 13th month. So is it reasonable to extend this model to the year 2009? I would say no, because we do not finish one cycle in 12 months. Because if you would then predict, use it to predict it, then things would be shifted because they'd be shifted off a little bit. And then each year, if you continue to use that same graph or same model, then things would be shifted off, and you'd be at some point predicting that in May it would be really, really cold, like 59, whereas in May it should be at 4, you know, into the 70s. So definitely I would not use this because it doesn't complete one full cycle in our, 12 months of the year. All right, that's it. Sorry so long.